So welcome to Kennedy Space Center, and today we're going to do a quick lesson on what friction is. So today I am by the Bianco granite-based stone here, and this stone, as you can see my hand slowly sliding across it, is forever rotating on another piece of granite down here. Now this rock weighs over 10,000 pounds, but a little bit of motion keeps it moving at all times. That's because it's on a virtually frictionless surface. So this is polished granite up against polished granite down here on the base. Now, if this rock were to not have water being pumped through at all times, allowing it to float and reduce the friction, there would be lots of friction. So the way that friction is quantified is there is the mass of an object, how heavy it is, and then, or how much stuff makes it up, and then there is the coefficient of friction. So for instance, let's say going across an icy surface might have, like a pond, an ice skating pond, would have less friction on it than something like, say, rubber against asphalt, which we intentionally want to have lots of friction to slow us down. So the greater coefficient of friction, the more those two substances against each other, the more they grip on each other. So two pieces of granite would stick together rather strongly. However, when pumping this water down here, it reduces the amount of friction and lets this 10,000 pound ball of granite continually rotate. So I might be able to stop it here. There we go, I've stopped it. And I can also get it moving. It's really hard because it's wet. We'll see how fast we can get it moving here. Mom, would you mind taking over since you're here? Thanks.
I can't see if I'm on it though. Here, wait.
And now because there's so little friction towards the base, this will remain rotating for a very long time because there's very little to slow it down, which is Newton's first law. An object in motion remains in motion unless acted upon by an unbalanced force. So the unbalanced force in this case would be friction, and because there's very little of it, this ball is going to remain in motion for a very, very long time. Now it's kind of a cool display here when you get up really close. You can see all of the different constellations that make up the ball here that float in the night sky above us.